Up we have pyramids, another category of polyhedra, since all of the faces are polygons, of course. Pyramids are classified by their bases, just like prisms are, but unlike a prism, a pyramid only has one base, conveniently shaded lilac in these pictures. Directly opposite from our singular base is a singular point called a vertex. Now, technically, all of the corner points, as we talked about before, are vertices, plural, and right across from our base, instead of having another base, we have just a single point, a vertex. In a prism, all of the lateral faces were parallelograms. What shape are the lateral faces for a pyramid? We can see that they are obviously triangles. And we still have lateral edges, just like we did in a prism. If we take a look at the bottom row here, we have ourselves first a triangular pyramid. This one very special, since you can make a case that any one of the triangles would be the base because all of the lateral faces are still triangles. Right here in the middle, have an obvious candidate for the hexagon as being the base. All of the lateral surfaces are triangles. And then we have the ones, of course, that are associated mostly with the ancient Egyptians. A square pyramid, shape of the base is a square. All right, so let's formally define a pyramid, shall we? So a polyhedron is a pyramid if it has one base and its lateral faces are triangles with a common vertex. So again, let me encourage you to draw yourself to the best of your ability an example of a pyramid and label all of the different parts. We have a base, of course. All of the lateral surfaces are triangles and they meet at a single vertex point. We still have lateral edges, of course. Now, I'm going to talk a little bit about the difference between the height of the pyramid, and we have another kind of height called a slant height. And the slant height is not the same thing as the height of the actual pyramid itself. The slant height is the height of one of the lateral triangles that make up the lateral surfaces. Now, another relationship between a height and a slant height, if you connect this point down here to the bottom of this point, here, I'll even do it for you. If you connect these two, it makes a right triangle, which means that you can use the Pythagorean theorem to find one of those shapes, either the slant height or the height, if you were missing one of them.